Welcome to Brain Vision.
In part A, we want to figure out the velocity that the human must leave the ground in order to reach a height of 60 centimeters. And so V naught is our unknown. Our final V is 0. Our distance traveled is 0.6 meters. And our acceleration during this time is negative 9.8. So to solve this, I'm going to use the kinematic equation v squared is equal to v naught squared plus 2 times the acceleration times x minus x naught. Plugging in our known values and solving for v naught, I get a value of 3.43 meters per second. Part B is just asking for the free body diagram. And so we have a force down of gravity, and it's equal to mg, which is also equal to the weight. And then we also have a normal force upwards. And that's all we have. And so for part C, I'm going to apply Newton's second law in the y direction for the free body diagram I just drew. Now the acceleration in this case is certainly not 0. And so this implies that N minus the weight is equal to mass times the acceleration in the y direction. Or N is equal to weight plus mass times acceleration in the y direction. So now we need the acceleration. Well, we have to analyze the motion again. In this case, v naught is 0. We're starting completely from rest. And our final velocity is the initial velocity of the part A calculation. So it's 3.43. In this case, x minus x naught is equal to 0.5 meters. So we're going to use the same kinematic equation, except we're solving for something different. In this case, we're going to use x minus x naught and our velocity values to solve for the acceleration. When we do that, we get an acceleration of 11.76 meters per second squared. This is the acceleration that the human rises in the crouched position to get a velocity to leap up in the air. Now we just want to sub this in. When we do that, we get n is equal to g times the acceleration y over weight. Here I just replaced the mass with g over w because it wants the answer in terms of the weight, plus w, or 11.76 g over w plus w. And this is where I left my answer, but you can plug in a value for g if you like.